not least, I would like to invite Nancy Yacovzada and Michal Ben-Neria. They are both experienced developers with a vast background from high-tech companies, a research assistant at Tel Aviv University under the supervision of Professor Irad Ben-Gal, as data scientists of the cybersecurity research group. They based fundamentals of the personalized security system for organizations. Please, our last two speakers, please.
Doesn't matter. Good afternoon. We will present our joint work of Nancy Yacovzada and mine under the supervision of Irad Ben-Gal. Our work is part of the cybersecurity research group, as Dr. Toch just mentioned a few presentations earlier. I won't describe the whole system, but the group aims to suggest a user-adaptive security system for organizations. Our component is the one that models the user's risk profiles and the web page's risk level using machine learning algorithms. And let's say we are an organization that we have two employees, Tui and Chris, and both of them trying to reach the Pirate Bay site. And we as an organization would like to define the transactions of the two if they can harm the company. So let's say that we have an Oracle system that can generate and predict the security level of all entities in the system, can be employees and web pages as well. And the system learned from Stewie's history that he's very clever and very careful in the cyberspace, and Chris is not. So that's why he gets the higher risk score. And the Pirate Bay is, of course, can be a risky site because we can download malicious softwares and ransomware and etc. Similar stuff. So as an organization, we can define that the transaction of Chris may be risky for the organization and the one from Stewie is not. So we believe that a user who visited a known malicious site in the past is more likely to be less security aware, and hence he can probably visit more malicious sites in the future. So we assume his risk score to the organization should be increased. And similarly, if we can track his web path through the cyberspace, we can potentially find more malicious sites that are unknown as for now. And if a site gets a lot of traffic from risky users, we believe it says something about the risk level of the site and it should be increased. So the interaction between the user and the web page risk scores or feedback, we believe should be iterative and till some convergence. We will describe it later. So in general, our main inputs of the system are HTTP logs, which gathered from an American toolbar company. I must say that the logs are very raw. We don't have much features. We don't even have cookies. And we generated blacklists of known malicious sites that we took from known lists from the internet. And our system is containing two main submodels. One of them learns the user's risk profiles and behavior over the cyberspace. And the second one is the web pager's learning. I'll describe the second one. So let's say we have a site that we would like to define its risk level to the organization, and we have two users, one good and one risky, one bad. And the good user moved from Facebook to this site and then to Amazon, and then the bad user, the risky user, the naive one, moved from a malicious site, let's say it has a drive-by download, then to the requested site. So if we will look at the traffic, the type of traffic this type got from the users in the organization, we can define its risk level. We do it by applying link-based ranking and algorithms, such as PageRank or Hubs and Authorities or Salsa. And that's how we propagate the user's risk scores over the graph, and we can get the risk score of each web page. We will continue with Nancy.
Okay, so I will talk shortly about how we learn the user behavior. So if we took the raw data, the HTTP logs, we can create two major data structures. The first one, the first one is the user pages incidence graph, where it represents the relation between users and pages, web pages, where the metric entries is 1 if the user visited the web page, and in the same manner, it can be a weighted graph that the weights are from the risk ranking framework that Michal just talked about. And you can see that this graph is very big, very sparse. On the other hand, we have another different structure, the browsing behavior features, which basically represent the behavior of the user over the web. For example, what is the percentage of the risky activity per part of day, or how many IP changes does he have in a short period of time. My work suggests a unique way to fuse these two data structures into one similarity graph. Then this graph represents users, and edges of the graph are the similarity between the users. And then our task is to do a segmentation of the users and find the security-related communities so we can profile each user in the organization. That is made by a spectral clustering algorithm. So again, we have two sub-models. One is learning the users, the other is learning the web pages. Each one of them generates as an input a risk score, and output a risk score, and this output is input to the other model. So this is basically a close feedback that it's iterative and updates dynamically. So let's look on an experiment we made. The preliminary results are very encouraging. As you can see, we compared 4 known algorithms, a ranking algorithm as PageRank and Hubs and Authorities, and we measured the accuracy of each one of them when we had the R method, the one with the feedback, and we compared it to the baseline, which doesn't use the information about the user risk profile. So our evaluation measure was the accuracy, meaning how many risky websites did we detect, and if the websites that we said that are not risky, if they are really not risky websites. And we can see that at each iteration, the accuracy increased when we had feedback. So as a conclusion, we argued that modern security solutions should use also information about the users that enters the web pages, and not only the web pages code or linkage. And that's it. Thank you.